Today we're going to talk a little more about position, velocity, and acceleration, except we're going to use integrals since that's something that we're new to. And so the theme for today is going to be distance and displacement. So just to remind you, the distance is how far you actually traveled. You know, if you run 4 times around the track, but you end up in the same spot you started, you still ran a mile, even if your displacement was 0. And so displacement is how far you are from where you started. And so I'll kind of give you a quick example to illustrate the difference. All right. So yesterday was election day. And, you know, at lunch, after my college algebra class and before my linear algebra class, I went and, you know, cast my ballot. And now for simplicity, we're going to assume that the path from me to the polling place was a straight line and that my velocity was more or less constant. Okay, so you can envision me sitting here in my chair, you know, where I oftentimes am, at time 0. Yes, you can, 141. All right. And so I started out here, and then I start out heading towards the polling place at a constant velocity. And then I get to the Randalls on 620, and, well, I'm going to stop. Because right there, I'm at the polling place. Looks like I might need a little more time. I'm going to extend the time axis a little bit. And then, you know, I was there and I spent some time casting my vote. The line wasn't too long there. So there, you know, here I am with no velocity standing at the polling place. And then I turn around and go back on that straight track back to my desk for 4th period. And then I arrived. Okay, and so that would be probably about like that. Okay, and those are supposed to be the same length. Suppose that the same amount of time was spent going to and from the polling place. Okay, so if you think about it, my displacement, if I started sitting here in this chair, and I went and voted, and I came back, and by 4th period I was sitting here in this chair, well, my displacement was 0. Okay, so we're expecting displacement equals 0. But my total distance traveled, you would see if you looked at my car before and after, the odometer had increased. We'll say it was 2 miles to the Randalls and 2 miles back. So I would expect that the total distance traveled would equal 4. All right, so in terms of the velocity graph, we have to think about, okay, which is which? We know that we're integrating. Okay, so if we go and we just find the area under the graph of velocity, we would see that these two areas were equal, but since the trip back, I had negative velocity. I counted negative as we were accumulating that velocity. And so the integral from v to t, or from, say, time 0 to time, say the whole trip took half an hour. So the integral from 0 to 30 of v of t dt was equal to 0. So that means that the displacement is given just by the integral of velocity, counting positive and negative. So but the total distance traveled was not 0. So how could I find the total distance traveled? Yeah, so they were saying something about absolute value, and that's true. But really, I want this area right here to count positive. Okay, so really what I want to do is I want for this to be any velocity to be positive. Really that would be, okay, adding this to this one. But really what I did to get this purple line up above is I took the absolute value of v. So we'll say that the distance is equal to the integral from 0 to 30 of the absolute value of v of t dt. Okay, so the rule is that the total distance traveled is the integral from t0 to t1 of the absolute value of v of t dt. Now the thing is that oftentimes this is something that we need to either split up into multiple integrals or use technology to find. I'm more of a fan of using technology because for Cal BC, the likelihood is that our particle motion problem is going to be two-dimensional. It's going to be given parametrically, which we'll study in the spring. But the thing is that the way that we express the absolute value of a vector is all of a sudden going to be something that we are very unlikely to be able to anti-differentiate. So it becomes a calculator question. Okay, and then the displacement of an object between t0 and t1 is going to be given by the integral from t0 to t1 of just regular v, because it will count negative velocity as negative. All right, for example, the velocity of a particle moving along a straight line is given by v equals -1 plus 2 sine t for t between 0 and pi. Is the object to the left or to the right of its initial position at t equals pi? Well, if we're just talking about at t equals pi, where is it compared to where it started? That's displacement. Okay, so I need to calculate the displacement of the object. And so displacement is going to be equal to the integral from 0 to pi of -1 plus 2 sine of t dt. We know how to do this. Okay, we're going to take an antiderivative, so that would be -t minus 2 cosine of t as t runs from 0 up to pi. And that's going to be -pi minus 2 cosine of pi. Well, cosine of pi is -1, so it'll be plus 2 minus, -0 is 0, minus 2 cosine of 0 is -2. All right, so I've got -pi plus 2, and then another plus 2 is equal to -pi plus 4. So what are we thinking? To the left or to the right based on this? To the right. But why? Yeah, because 4 is bigger than pi, therefore -pi plus 4 is going to be a positive number. So I conclude that the particle is to the right of where it started. All right, so we conclude it's to the right. Okay, so the next one I've got is a particle moving with velocity along a straight line given by v equals sine of x squared plus 2x plus 3 for t between 0 and 2. What is the total distance traveled by the particle between t equals 0 and t equals 2? Well, I know how to do total distance. I integrate the absolute value of velocity from 0 to 2. Absolute value of v of t dt. Okay, well, that's the same as the integral from 0 to 2 of the absolute value of sine of, well, whoops, that should have been a t, right? I can fix that. T squared, 2t, and 3. I'll fix that. Now, the sine of t squared plus 2t plus 3 is something that I can already tell you it doesn't have a closed form antiderivative. And the absolute value of that is just even more hopeless. So what we're going to do is we're going to pull out our TI-84. Okay, so you can see I've entered sine of t squared plus 2t plus 3 into y1 on the calculator. You know, in case I wanted to do an analysis of the graph or I wanted to look at something. But there's also some other reason that I did that, so I could show you something. Okay, I'm going to go over here and I'm going to quit. And I'm going to integrate. Now we get the integral by pushing math and 9. And if you have a TI-83, it's a different syntax, and I will show that to you, but I'm not going to be including that on this video. Okay. So we're taking the integral from 0 up to 2 of the absolute value. Absolute value is under math. So we go to absolute value and we go over to number. We're going to take the absolute value of a number. And the thing that we're taking the absolute value of, I've already typed into y equals. In fact, it's y1. So I'm going to go over here to variables, which is right next to clear. Y variables. We're in function mode. Later on in the year, we'll use parametric and polar mode. But not as much as you might think. Okay, we're going to choose function mode, and we're going to call on y1, because that's where we stored sine of t squared plus 2t plus 3. And it knows what you mean. Okay, so we're taking the absolute value of y1, we're integrating it with respect to t, And we're going to press enter and have the calculator do the work for us. And then it thinks for a while and it concludes that it's 1.217. And so that's the total distance traveled. Okay, if we look at the graph of this thing, we'll see that it was negative for a while, and then it was positive, and then it went negative again. Okay, so the displacement would most likely be negative. But if we count all of this area, you know, the odometer, it doesn't care if you're going north, south, east, or west. It's just going to keep piling up the miles. And so, looks like this particle traveled 1.217. So this is one from the review quiz. The graph of the velocity of a particle is shown below. The distance the particle traveled is 20. Okay, so that means that the integral of the absolute value of v of t from 0 to 6 is equal to 20. And the displacement is 12, meaning the net signed area between 0 and 6, just the regular integral, is equal to 12. So basically, there is going to be, we're interested in just this area down here that I shaded in gray. And so we're interested in that. Well, I think the thing to do would be to call each of these areas, just in terms of their just positive area, and call it A and B. And you can probably figure this out some other way, but this would be like, you know, the most algebraic way to solve this one. A plus B, just the total area without thinking about positive or negative, equals 20. And then A minus B, which is the integral where area underneath the x-axis counts as negative, that's equal to 12. So what I'm going to do is I'm going to do old-fashioned Algebra 1 elimination. Yeah, hear that excitement up in front? 2A is equal to 32, meaning A equals 16. Therefore, B would have to be 4. So, what does that make the integral from 4 to 6? Any thoughts before y'all leave? Yes, it would be, but what's the actual number that it is? Wait, I'm thinking negative 4. Where are y'all getting negative 8? I don't know where y'all getting negative 8 from. You know, some people say 4, some people say, evidently some people say negative 8. But I'm saying negative 4. Okay, y'all have a good one. And I think that's where I'm going to end the video as well. So y'all have a good one as well.